Ramohan Rao and the coordinators of this particular FDP, and all the participants who are on board, who are online. Very good morning to all of you on behalf of Vasavi College of Engineering, the management, the principal, staff, and students. Cordially welcome to the inaugural session of this particular FDP. I take the little privilege of presenting the brief profile of the college. Vasavi College of Engineering has been established in 1981 by the late Venkatesham garu, former statesman, former governor of Bihar and Karnataka, who has established this particular college with an objective of offering technical education on non-commercial basis. And college is offering 6 UG programs in computer science engineering, civil engineering, electrical and communications engineering, electrical and electronics engineering, information technology, and mechanical engineering. And 5 MEM Tech programs in various engineering disciplines, including one of the program being offered by Department of Mechanical Engineering, which is ME in Advanced Design and Manufacturing. The college has been conferred with autonomy by UGC in 2014-15 for 6 years, and consequently got extended for 10 years up to 2030-31. College has been accredited by NAC with A++ grade in 2021 for 5 years. And all UG programs have been accredited by NBA up to 21 June, and further we have applied for the reaccreditation, and we are waiting for the visit in the month of October or November 2021. And coming to the success story of Vasavi College of Engineering, or the salient points of the Vasavi College of Engineering, if we come to that, this is the most opted college by the MSET aspirants, Telangana State MSET aspirants. More than 75% of the seats are filled by the students who are having 10,000 rank in Telangana State MSET aspirants. And coming to the Category B admissions, where this is the only college which will be filling all Category B seats based upon the merit, that means based upon the JEE mains rank. I'm glad to inform you that more than 75% of the seats, they are filled by the students who are having less than 60,000 rank in the JEE mains. Coming to placements, even during the pandemic times, our students they are able to secure good placements. Most important, all international MNCs, they are visiting our campus. During the 21 passed out batch, nearly 950 gross placements happened, 478 net placements happened, and about 68 companies they have visited, and average pay package it was around 5.25 lakhs per annum. Even this particular 22 passing out batch, that means the present final year batch, even in spite of that coming into the final year, already 18 companies that visited the campus, nearly 253 net placements happened. So this is the effort of the students, of our students, as well as the faculty, and the visionary management with which during pandemic times also our students, they are excelling well in their higher studies as well as the placements. And coming to this particular FTP, definitely this particular theme of the workshop or FTP, that means vibrations and condition monitoring, as told by Professor Ramon, this is the need of the hour, definitely. Long ago, 10 years back, when I was there at the previous college, GMS of Technology, which is nearer to NSTL, Visakhapatnam, along with my guide, I was the active person in this Condition Monitoring Society of India, CMSI, where we have, even along with my guide, we have conducted several experiments because my guide, Professor K. Ramjigar, he's the active part, took active part in the NSTL R&D activities, where he used to engaged in consultancy works. Where I was a member of the CMSI, where definitely condition monitoring based upon the vibrations, the bearings or any machine structures, definitely they have to be addressed so that prevention is better than cure. So that is a major theme of this conditional monitoring, where the level and amplitude or the level of the vibrations, they should not spoil the machine. So you have to monitor the condition of the machine so that it will not get damaged. So prevention, this is the prevention policy or the prevention mechanism underneath the point of this CMSA, condition monitoring. I congratulate Department of Mechanical Engineering for choosing this particular theme, and definitely the hands-on sessions which are planned, they'll be adding value to the keynote speeches by eminent professors from IITs. They have been scheduled during this FDP. I thank Professor Venkatesham Garu for supporting the Department of Mechanical Engineering for coining this particular topic and making all the sessions in the coming days very fruitful for designing all the sessions. I once again congratulate all the participants, and I thank all the managements who have deputed the participants to this particular FDP. And I wish that all the sessions will be going with the utmost deliberations. And I congratulate once again the Department of Mechanical Engineering. Thank you. Thank you, Ramon. Yeah, Ramon.
Okay, thank you, sir, Principal, sir. Now this is the time for conveying the vote of thanks of this. First, I thank our beloved principal for sparing his valuable time and addressing the occasion. And I thank our HOD, G. Ramora, sir, for all his support and encouragement for conducting this FDP program. And I thank Venkatesham, sir, IIT, for inaugural session to attending for the inaugural session, and also I thank Abhijit Sarkar, sir, for your valuable time for sparing this inaugural session. And now I thank all the participants, and we have received 152 participations from across all the states from India, and particularly from Kerala 20, Tamil Nadu 20, Jammu and Kashmir some 4, and many participants shown interest. We thought initially this is the narrow subject like vibrations. Later we realized people are very interested in this topic of vibrations. And by the end of this program, the participants will enhance their knowledge in the field of vibrations and condition monitoring, and also will be acquiring inputs in realizing their research goals. And I thank one and all for participation of this inaugural session. Now it is the time to invite our keynote speaker, and I request our other coordinator Rajendra Prasad sir to introduce Venkatesham sir and Abhijit Sarkar sir for today's session's speakers. Please proceed, sir. Thank you one and all.
Thank you, sir. And now it is time to introduce our valuable speakers. The first one is our most respected Dr. B. Venkatesham, sir, who has been a constant source of inspiration from IIT Hyderabad. He took the initiation and he supported us throughout this particular project. Today's expert speaker, Dr. Abhijit Sarkar. Sir, thank you, sir, for your time your interest in conducting the online session and hands-on session for the participants. Now, let me introduce you, Dr. B. Venkatesham, sir. Dr. B. Venkatesham is an associate professor in the Department of Mechanical Engineering, IIT Hyderabad. The interests of Dr. B. Venkatesham are vibrations and acoustics, and his current research interests include vibrations, engineering acoustics, industrial noise control, acoustic structural coupled systems, and sound quality. Dr. Venkatesham is a PhD from University of Sciences, Bangalore, and he has a rich industrial experience also prior to this teaching experience. He's a lead engineer in GE Global Bangalore, and he's a research engineer at the same institute, and he's a mechanical engineer at GE Global prior to that one. And he has been a valuable source of inspiration for the Department of Mechanical Engineering. uh, Vasavi College of Engineering. And we wholeheartedly thank him for the support extended. Now, let me also introduce the expert speaker of today, Dr. Abhijit Sarkar. Dr. Sarkar is an associate professor from IIT Madras. He too holds his PhD from Indian Institute of Sciences, Bangalore, and his area of interest include mathematical formulation and analytical solution of problems in dynamics and acoustics. And we look forward for his expert lecture at 11 o'clock. And Dr. Sarkar is having around 40 publications in very reputed international journals. And he too has a prior industrial experience, like he worked in, he's an engineer at Tata Motors and Aton Technologies prior to his career in teaching profession. And right now it is time to invite Dr. B. Venkatesham sir to go ahead with the keynote address and address the participants on the latest trends in vibrations and conditional monitoring. And after that, the session will be followed by Dr. Abhijit Sarkar, and the session is a hands-on session on the beam vibrations as indicated to you earlier. So thank you very much. And now I welcome Dr. B. Venkatesham sir to take on the session. Thank you, sir.
Okay. So good morning to all, and first of all, congratulations to the Mechanical Engineering Department taking FDP on vibrations and condition monitoring. And welcome to Professor Abhijit. So he was my lab mate. So I'm happy to see him again here.
Yeah, virtually though.
Ideally, we're supposed to meet by physically. Okay. Just with the interest of the time, so I would like to stick to the 11 o'clock because that is a more fruitful sessions. So I will try to give bird eye views about the condition monitoring aspects. So I will try to adjust the time accordingly. So I will make sure it's 11 o'clock. We'll hand over the session to Professor Abhijit. So then anyway, I will be come back again. If you have any doubts, we can try to discuss. So maybe I will come back another 2 sessions, and day after tomorrow and again on Friday. So we can deliberate more. But today I will try to give why I need to study vibrations, especially the mechanical vibrations. I'm talking about it because vibrations has a different mean. At IAC there is a cultural event called as vibrations. Okay. Okay, so that is the reason I'm telling it's like a different set of things, but we are talking about mechanical vibrations. So give a minute, I will try to share my screen. Yeah, are you able to see my screen? Are you able to see my screen?
Yes, sir. Yes, sir.
Yes.
Yeah, is my voice is clear?
Yes.
Yes, sir.
Clear.
Okay. So before starting this, first, what is the condition monitoring in a simple layman terms? Okay, are you clear? Yeah. So if in a simple layman term, somebody asking condition monitoring and mechanical machine condition monitoring is a simple question. If somebody is easy to relate, it is if somebody joined in hospital, think about it. Okay, somebody joined in hospital. It's like you want to check what is his condition, right? So if it's very serious, he was in ICU or ICU, then he will recover it. Then he will come to the room or then he will comes to the general ward, then discharge, right? This is the way we'll try to talk about it. A person's health conditions, we are talking about, we are monitoring him, right? The condition of this health condition, we'll try. There's a common word used in our day-to-day life. How is his condition? Okay, how he is recovering? His condition is monitored by the doctors or not? So then obviously what will happen, the tool, the parameter they try to monitor is, okay, his oxygen levels are good, his temperature is the normal temperature or not, his BP is, the common parameters will try to monitor it, right? Okay, fine. This within the allowable limit, okay, his hemoglobin, like you would try to identify various parameters to declare his condition is safe condition or his condition is not good, right? So the analogy you try to think from the machine point of view. Okay, which parameter I need to measure? Can I declare the machine is operating good or bad, or is there any corrections to be taken care. Okay, so one of the parameter is vibrations. So as part of this FDP, what you are trying to do is this analogy, as I said, like a human being is monitored in hospital at various parameters to declare is doing well or not. Same way, we are trying to understand the condition of the machine, okay, and declare it how it is operating, or is there preventive maintenance, or like the regular maintenance. What is the maintenance like scheduling of the maintenance? Everything can be worked out. But what parameter can be identified or what parameter can be monitored? Okay, so what is the real indication of this parameter? One of the critical parameters is vibration. So as part of this FDP, you try to talk about monitoring the vibrations and condition of the machine in various applications, and how to do that is the ultimate aim or objective of this FDP. Okay. If you see the typical mechanical systems, okay, I'm talking about mechanical systems. Okay, we can broadly classify them. One is the driving element, other one is a driven element. Okay, one is the driving element, other one is driven element. This driving element and driven element connected by the transmission element. Okay, driving element and driven element connected by the transmission element. So a quick view, what is the driving elements? So whatever we have is IC engines, okay, is a driving element. The power generating ones will come under the driving broadly. So we have motors, IC engines, the internal combustion engines, whatever the combustion based, the energy will be generated. Okay, the electrical energy will be converted into mechanical energy most of the times in the motors, and the turbines. Okay, so look, we are trying to see in our power generation units, they're also the mostly combustion based energy will be generated. So these are driving elements. These driving elements connected to the driven elements like pumps, like compressors, like generators, through means of the transmission elements. As part of the transmission, what we try to do it, either we can transmit the power, okay, or we control the power or modify the power. Right, whatever the power generated by the driving, we are trying to transfer to the driven, okay, more efficient way. In this process, we are trying to use the transmission elements. What about transmission elements? So either we'll transmit it or modify, okay, the form of energy, you try to modify it or you try to control it. For example, brake is a good example of controlling. Okay, so if I want to control the driven operations, you can use the brakes, right? Belt is one of the element for transmitting power from the driving to driven. Couplings, so there are rigid couplings. This is as part of your mechanical design course, you try to discuss about all these transmission elements. Okay, design of transmission elements is your objective in your course, how to design them, what type of failure modes are there, and all the things, right? So bearings is one of the critical element. So if you look at it, operations of this driving, transmission, and driven, okay, all these mechanical elements, so they try to give some signature. When they are operating, they try to give some signature. Okay, those signatures will try to understand. Those signature will try to understand. Okay, but in the mechanical systems, what is the beauty of this is, if you observe almost all the major things, nowadays many engineering colleges are thinking that what will happen to mechanical engineering, like because most of the opportunities are there for the non-mechanical students, what will happen to the mechanical? There's a very simple answer. As long as your rotating components are exist in the universe, so we are exist. Okay, simple. As long as your rotating components are existing, so we are existing. So this is a simple way we can try to do that. But yes, the rotating mechanism may be changed from the over the years, right? It's a rotating, it will try to do that. Why I'm talking about the rotating? Because when the particular component is rotating, it will try to convey the information about their operating conditions through the some forms, like whatever the forms will try to look at it, but it has an association with the rotating components. It has association with the rotating components. So monitoring the speed is one of the critical aspect in condition monitoring. So monitoring the speed is another important point. Then the next question is, why condition monitoring or mechanical vibrations are become prominent? Okay, why it's prominent is, unfortunately, the complete design is looking at is high power densities driving and the power units, input units. High power density means obviously what will happen if you try to look at it. I want to get more power from the small compact devices. When I go for a small compact devices, so then obviously to get a more power density, what we need is speed should be increased. When your speed is increased, okay, the speed is increased to get a high power density. So obviously what will happen, your dynamic forces in a simple terms is centrifugal dynamic. One of the component of the dynamic forces is centrifugal forces, that is proportional to omega square. So your omega square increased. So then obviously one side you are reducing the weight by putting lightweight structures, other side you are increasing the speed. So your input excitation is increased and your system will become a flexible or like a lightweight. So obviously your response will be amplified. So with these two considerations, now vibrations are becoming prominent. Vibrations are becoming prominent. In a couple of years back, a couple of decades back, vibrations was not that key attention parameter, right? But now it is why the people are, because of the speed is increasing, right? It is becoming a prominent in the process. So yes. So as I said, if you have rotating components, if it's high speed applications, obviously vibration is one of the key output. Okay, we want to understand that. So when you are designing and operating any machine, okay, always we'll try to start with the designing for reliability. Design for reliability means if you try to design a component, it should survive for particular rated life, right? That is very important. So the reliability will be defined. For that, when you try to design a system, you try to talk about it to maintain the reliability. So shall I put the backup components, or how to address the reliability? So as part of the design, we always take it reliability into consideration when we are doing the system designs. Okay, not only the designs for the reliability point of view, because that decides your availability of the component. That decides your availability of the components. Then what will happen? So to make the particular intended product, okay, to do the required operations, okay, we need to have a proper maintenance protocols. So when you try to talk about a proper maintenance protocols, so obviously you need to monitor. Okay, is it really how you know that is a proper maintenance? For example, always the doctor suggests, because I'm taking more human life, because everybody can connect it. Most of the time the people said after 40 you need to go for every year medical checkup, right? So that is a recommended, but sometimes we may do, sometimes we may not do it, but impact will be long term. You have impact is there. Same way that we have a standard maintenance protocol given by the OEMs, means the original equipment manufacturers, but we need to do proper maintenance. So what is the maintenance schedule, how to do that will decide it. Okay, based on that one, whatever measurements to be conducted. Okay, I want to do the prevent, as the principal said, like preventive maintenance is one of the important. Yes, when you try to do the preventive maintenance, okay, what type of measurements I need to do it, what parameters I need to measure it, what parameters I need to measure it. Okay, so for example, shall I need to measure temperature, or shall I need to measure the vibrations? Shall I need to measure the sound? Shall I measure the oil quality? For example, you are using lubricant, right? Oil quality. Or if I am using electrical equipment, shall I measure the current? Okay. Shall I measure the sound in a lower frequencies or higher frequencies? What else? Okay. What parameters we'll try to address as part of this MDP? Okay. Then once I decided what parameter I need to measure, what type of instrument I need to use it. Okay, that is also important. If you use the wrong instrument, okay, you may get a misleaded data, and taking a decision based on the misleaded data will be use the unintended results. So obviously you need to select the right instrument. So that operation, when you try to do that, you need to know the right instrumentation. Yes, I got the data. I use the proper maintenance schedule is given. I'm monitoring the proper measurement parameters. I use the right instrument. I got the data. Okay, if I don't know how to interpret it, okay, it's like a operation success, patient died. So you'll get the information, but there is no use, right? So yes, we need a proper interpretation. For that, you require a physics, how to interpret that thing. So you need to understand the component or product, how it works, and how to interpret it. There the physics will help you in that. So this is the typical design and operation cycles are involved. So you need to learn as part of the condition monitoring, all these aspects. And what are the indicators I already mentioned? So for example, something is not working, your human body is not working, the temperature is one of the quick indicator, right? So in a machine also same thing, something going wrong means obviously losses are increased. The losses are dissipated most prominently in heat form. Okay, whatever is not efficiently running, the losses will be will be radiated from the machine. One of the indicator is the temperature. Other one is the oscillations of the machine from its equilibrium position is vibrations. Then that vibrations leads to the sound. Okay, but the sound measurements may not be always is viable because operating the environment may decide is it right or not. Okay, then as I said, like if you have lubrications, by monitoring the whatever particles are there in oil, by doing the tribological aspects or monitoring the tribological aspects, by doing the oil analysis, so either wear is happened or not, whatever components are coming in that, okay, doing that oil analysis, also you can assess the condition of the machine. Okay, then this is the another one is called acoustic emission. So at a micromechanics point of view, the amount of energy released, you'll go at the surface waves. By monitoring surface waves, the people can use the acoustic emissions. Nowadays, many people are using this acoustic emission as one of the tool, especially in a compositor, because I know in around Telangana and Andhra, majority of the faculties are doing PhD in composites. So there the acoustic emission is popularly used. Okay, acoustic emissions for the surface waves, the micromechanics ones. Then as I said, my frequency of interest is above the 20 kilohertz, and we can think about ultrasounds. Okay. Then as I said, if it's electric motors, then you can try to do the current signature analysis. Okay. These are the various indicators. It's not an exhaustive list. It's like a clue. Yes, I want to do condition monitoring. I need to choose a parameter or indicator to assess the situation of the machine. Then if you could take it vibration as an indicator, because 70% of the condition monitoring, the indicator is vibrations. Okay, indicators is vibrations, because we are talking about mechanical vibrations. Obviously, the system is rotating. Rotating means obviously it has some any dynamic effects that will give you as a vibrations. So generally, the vibrations will try to classify. It's just a beginning. So we'll try to report it within that. There are good number of standards established. So we have American Petroleum Institute APA standards are there, ISO standards are there, IRA standards are there. There is good number of standards, AGMA standards are there, ACMA standards are there, because these various components, the people have done a very detailed studies and given the standards. Just if you implement it, when you're doing this maintenance in a field, so you need to follow that particular standard, and they will say that, okay, within the particular displacement values or vibration velocity values or acceleration values, you said acceptable. So that type of conditions can be taken. So the standards are there in, for example, for fans, compressors, for gears, there are different standards are there. So you try to monitor against those standards and try to report it. But once you decided vibrations are serious, then you need to have two methods to be considered, or two things to be considered. One is because of the natural vibrations, or like free vibrations or forced vibrations. Okay, if it's a then we have the limit. Is a diagnosis journey or remedial journey. So what will happen? Shall I need to diagnose what is the problem, what is the fault, why it is generated? So I need to do that, or I need to remedy, I need to provide it. So the simple thing is natural frequency of the system matches with the excitation frequency, then you will get a resonance. So at resonance, so either we need to separate the excitation frequency and natural frequency. Sometimes it's not possible, then you need to go for a passive methods, that is called the damping. Okay, so yes, there are bad parts are there, or whether you need to modify the forces, or you need to modify the natural frequencies. Okay, and by changing the stiffness and inertia. Okay, this journey, how we'll try to do it, maybe you will try to come across for various industries, so as part of the next lecture series. Okay, for example, in a motors, by understanding the operations of the machine, for example, your fan, that is 3 blades are there and rotating at 1500 rpm, so you may see a blade passing frequency in your signature. Okay, so those things you can try to do that. Now, yes, we are able to understand, yes, vibration is key important. Understanding fundamentals of vibrations will help to understand the faults in the system and monitor the health condition of the system, or like a mechanical device. But what is the new opportunities? What are new opportunities we are trying to see? Especially somebody wants to pursue the condition monitoring as their PhD topic. What type of opportunities we have it? So if you look at it, the major things are, as I said, the maintenance schedule is decides the most of the things how to do the more availability of the machine, because your return on investment will happen based on the availability of the machine. So for that, you need to have a proper maintenance schedule. We need to have it. Okay, then as I said, the data is coming, lot of data is coming. Previously, most of the research was physics-based models, physics-based models. Now we have because the computational efforts are there and very good data-driven algorithms are coming up. So what I mean is machine learning and data science and AI. So the people are using this for analyzing the customer preferences, those things in various industries. But the same thing can be deployed in our condition monitoring. So the data analytics, okay, data analysis method. So now I can take a decision based on the data driven approaches than the physics based. Yes, physics is required, but data driven approaches can be leveraged to take the decision and to make it more efficient decision, and with a less skilled manpower also can take some decisions. So that is where you can use that. And instrumentation, previously we used to have a very big devices, signal processing devices, analog devices, those things. Spectrum analyzer means we need to carry at least a couple of kgs, like a 1 kg 2 kg ones. But fortunately now we are moving towards the smart devices. So any big computational resources are increased. Once upon a time 18 GB computer itself is a big one. Now 18 GB, it's very easy to handle it. Okay, your mobile itself is a 64 GB, right? So now people are moving from the very high-end computers, laptops to the smart devices. Like a will be like your mobile itself is a device, or a tablet. So then what happened? Completely the instrumentation is changing. Even you may not really require high power. It will be available in cloud. Just you need to connect it. Your mobile will be just as like a monitor. That's it. So everything is connected to the cloud. So these smart devices are coming in instrumentation. Then yes, then people are interested to do the real-time monitoring. Okay, previously what happened, the sensors are deployed and in a factory, and some control room is there, and the decision will be conveyed to the manager, okay, through the SMS or something like that. But now what happened, anybody can look at it, okay, and what's happening on the machine. So then they take the decision. So the designers and operators and management can try to monitor in real time, just because of the communication is happened. Okay, the latest protocols in a communication, the 5G comes, then obviously you have a more access to the machine to know the live conditions. So the real-time monitoring will be possible. See, but if you look at it, the majority of the development is happening on the electronics point of view, right? And even the circuit point of view. But the mechanical systems are as it is. So now what we are doing is we are trying to connect the mechanical, the non-circuit devices with the circuit devices. So we need to adopt the circuit devices development as part of the non-circuit devices development. So this will give you new opportunities for all of us to relook at it, these condition monitoring problems and vibration problems. Yes, as I said, there are other technologies, the two prominent ones I'm talking about industry 4.0. This is like you are trying to take the decisions between the machine and man, or human interactions will be involved, and connecting more than one machine also. So there are various technologies that people are talking about it, but you can see the most prominent one is the transportation. So smart mobility. So mobility is changing, game changer is happening in the mobility devices. So then you are making the system more smart by putting more sensors. So then obviously decision making will changes the things. So now, for example, we are talking about 3D printing and as well as the drone technologies and robotics. So yes, edge computing, those things more really directly related to the mechanical, but those will give a leverage for mechanical engineers and IoT devices. So Internet of Things devices. So you connect a device and that's connected to the internet, and then you can take the decision. So small smartness will come into picture. So yes, it affects appliances and as a manufacturing industries and automotive industry and infrastructure. Okay, everything will try to see a spectrum change. Okay, spectrum change in our technologies. So yes, it has an opportunity to do that. And one quick example is, for example, most of the times we say high-end research is happened in the aviation industry or space technologies. Then later comes to the automotive technologies. But now whatever is happened in the aviation industry now slowly moves towards the drone technologies. Okay, yes. Here what happened, the energy source might be mostly combustion based. Here the energy source mostly, okay, is electrical driven. But the challenges will be similar. Okay, the challenges from the vibrations point of view is similar. So the technology point of view is similar, but the application, the product may be changed. Similarly, car industry, like a typically car, now the people are talking about electrical vehicles. But if you look at it, the typical IC engine speed, maximum speed can go to 6,000 RPM. But in a motor, like to get a same power density, okay, you need to go up to 18,000 RPM. Means 3 times you need to increase the speed. Okay, the motor should run faster. So obviously you will get centrifugal forces more. So you may see more challenges and the vibrations point of view. Okay. Yes, it's like a new opportunities will be there in the smart mobilities. So the summary, quick summary from this is, yes, vibration monitoring is one of the critical parameter in condition monitoring. Okay, and data-driven approaches will help you in a condition monitoring. So right now, whatever the physics-based is there, will move towards the data-driven. So then you may see hybrid methods. So data-driven methods and physics-based methods to take the decisions quickly and do the smartness in your condition assessment. And people are interested more in real-time monitoring and the smart decision as a potential in long terms. Okay, so everybody wants to means like I'm talking everybody means like the management is more interested in make the product availability 100% is expected, but it may not happen, but everybody expect availability, and rate on investment should be return on investment should be very high. So then, yes, there is a new opportunities for all the condition monitoring engineers because of this new technologies coming in Industry 4.0 and smart mobility. With this, I would like to thank you for listening. Just a bird eye view about the condition monitoring and future aspects from my understanding. So with this, I would like to stop it.
Thank you, Dr. Venkatesham, sir. Well, you have given a wonderful picture of the importance of the condition monitoring, and you have given a lot of confidence to the mechanical engineers, quoting that until the rotating components exists, the importance of the mechanical engineering will persist. And of course, your explanation on why conditional monitoring and how the response is amplified in the case of lightweight vehicles with increase in the speed of the systems, and then your concepts on design for reliability and the maintenance protocols thereby, and then the vibration flow charts, and obviously you have not even left that introduction of artificial intelligence and machine learning as a part of new opportunities in condition monitoring, and your overview on the industry 4.0. I think really it's a very, very useful thing for the participants. And thank you, sir. Thank you, very much. And we will meet you, I say, we will be in touch with you very soon, sir.
Sure, no problem.
Sir. And now the next session will be at 11 o'clock by Dr. Abhijit Sarkar. And please make a note that all the participants make use of their, be available with your laptops, so that, there will be some hands-on session using Python for the beam vibrations. Okay, so we will join once again, say at 11 o'clock. So please be there at 11 o'clock. Sir, hello.
Yeah, yes, sir. Okay, if any questions from the audience, we are happy to, because
yes.
So we can.
If you have any questions, please, audience can come up with any type of questions in vibrations and condition monitoring. Dr. Venkatesham is ready to address.
Sir, good morning, sir. Hello.
Yeah, Dr. Praveen. Yeah.
Yes, sir. I am Praveen from Hyderabad, sir. Sir, I just want to know about more on AML for new opportunities. How we can apply AML to the condition monitoring, sir.
Right. So just one example I can give. Imagine you, this is the one is already available, but I will try to give an example. So most of the devices nowadays have the temperature monitoring sensor, right? Right. Even aircraft, because in aircraft, when they try to take off and landing, right, there are so many sensors are involved, right?
Okay.
Okay, continuously they monitor the vehicle, right? Aircraft. What a vehicle in this sense is aircraft. Okay, the data, so much data will be because, for example, aircraft is a long haul is like a 12 hours. Right?
Okay.
So you are monitoring the data for every minute.
Okay.
Right. So now imagine how much data points are collected.
Yes, sir. Yes, sir.
So now what will happen? Previously, we used to see the trend, is there abnormality is there, or like is there any? That's the way we'll try to take the decisions, right? And limits are there within the limit or within the limit. But now, if I have so much data, by using these self-learning methods, okay. So can we try to predict it? What is the life left over, or what type of the possible preventive schedule can we think about it? Okay. This is one thing. Or other option is, for example, as a maintenance, what will happen is generally we'll try to keep on monitoring the failure modes. Okay. In aircraft, for example, not aircraft, even power turbines and everything. You go to mechanic, for example, see your Maruti car. Okay.
Okay.
So generally they will do the oil checking every day. Like for example, they are trying to repair in across India, so many service centers, they try to change the oil. Doesn't matter. They will try to take a criteria, either the 10,000 kilometers, I think 5,000 kilometers, this varying from OEM to OEM, 5,000 kilometers, okay, or 1 month. That is the way they try to change the oil. Okay. Is it really worth to change it?
Yes. Yes. Sir, here a major thing is data collection.
Yes.
Is there any third-party websites to provide the free data? Is it there?
No, right now the most of the data from the mechanical engineer's point of view, okay, because other devices, for example, if you see the customer preferred, there is a open database is available, right? Open databases are available, but most of this for mechanical devices point of view, it's more unfortunately it's treated as a confidential information from the OEM's point of view.
Okay.
Okay, they don't want to reveal their product continuous monitor data.
Then how can we get the data? If I wanted to work on this one, actually I'm interested.
This we can try to need to collaborate with somebody, or otherwise you need to put the, for example, it's not a straightforward answer. Okay, frankly speaking, it's not a straightforward answer. Okay. You need to, for example, you are trying to monitor the gearbox one. Okay. Okay, generally the monitoring may not be happen in MSM because access to the MSMEs is easy comparatively the big companies.
Okay.
Okay, from the research point of, but at this moment the database is not for mechanical aspects point of view is not big database.
Okay.
I agree with you.
Okay.
Venkatesham, can I join? Can I add to your answer?
Please go ahead.
Yeah. So firstly, Praveen, I would like to give the example with which Professor Venkatesham started with. See, when you are considering even your health, the way the doctor will analyze it is he will, the stethoscope is actually a vibration measuring instrument, right? Stethoscope, you put it on the chest and the dhap, the chest vibration of the heart, which is coming on your chest surface, the doctor through his ears is actually monitoring it. So what we now need is a machine which monitors the vibration, let's say either of your pulse, which is exactly what your Fitbit type appliances do, or from your heartbeat. There's something, even these pulse vibrations comes as as a effect of your heart vibration, right? So if you can monitor this vibration, and let's say you have a Fitbit type devices which collects this data and puts it on some server. So what you want is that, my wife will get a message whenever I miss a heartbeat. So whenever my heartbeat pattern changes, so all you need is an algorithm which is sitting on a cloud, which monitors these heartbeats and is able to identify some unnatural pattern in this vibration and sets off an alarm to the user that there is some unnatural vibration. Now, whatever I explained in terms of heartbeat or pulse beat, the same can be extrapolated even for a machine. Okay. And coming back to your next question, that how can you collect data? I can tell you, let's say I'll give you another simple example. If you are riding a bicycle and the bearing of the bicycle goes bad, the first thing that you notice is actually the sound of your cycling changes completely. So again, all you need is a smartphone type devices, and we have done it, that using a smartphone, you should be able to capture the change in acoustic patterns of, you know, an ordinary bicycle, the bicycle which is running perfectly, and a bicycle for which, say, the bearing has fallen off or has gone bad. So once you hear that screeching sound, you send off an alarm that, you know, that it's time to replace the bearing. So you can collect the data, especially for low-end machines, not for high-end machines, at your own end by using as simple device as a smartphone. Okay, because smartphone has a microphone, and actually there are apps which can get you the frequency content of the incoming audio signal directly. So all that is possible. So low powered instrumentation, I mean what we call frugal engineering. Frugal engineering is engineering which is meant for the poor man. Okay, so we understand that instrumentation is always costly, but if you can use an existing smartphone to collect the audio data, maybe it will not be very accurate, but at the same time, when there is a large deviation, as you know, our ears itself can pick up a difference between a healthy bicycle and a bicycle where the bearing has fallen off or the chain has not been oiled properly. So those type of, you know, large differences in the audio signal, or maybe if you have a flat tire in your, you know, this in your bicycle, you will have a very bad ride. So if you have, I mean, I'm saying audio because audio can be captured through your smartphone. Vibration, it's difficult to capture through smartphone. It's possibly not, it's not possible to my knowledge. But audio signal can be captured through your microphone, and you can get some meaningful result using the same AI type algorithms. Please remember, AI is glorified regression. I know I am getting recorded, but AI is not a new thing that has come in the market. It was there in its previous avatars as, you know, various numerical algorithms or, you know, regression type algorithms. So those algorithms can be used on the data, and you can make some useful predictions. So I would believe that it's not completely the end of the world for you if you don't get data. You can get data from at least the audio data should be accessible to you. Yeah, thank you, Venkatesham. I just wanted to add that.
Sir, thank you your suggestions.
Thanks,
And
sir. Thanks.
thank you, sir. Sir, I just want one more thing, sir. Can I ask, sir?
Hello, good morning, sir.
Sir, good morning, Anjani, sir.
Yes,
Yeah,
sir.
yeah,
Yes,
please,
sir. Yes,
please
sir.
go ahead.
Please.
Please go ahead.
Sir, if don't mind, can I ask one question, sir?
Yeah, please.
Okay.
Please, please.
Okay. Sir, myself, Raghunatha Shetty, I am calling from Venkatesham Engineering College, Ballari, Karnataka, sir.
Okay.
Yes, please.
Hello, sir.
Yes, please. Yes, please.
Sir, nowadays the sound and vibrations totally integrated with IoT and AML. I'm basically from mechanical, sir. It is difficult to study and understand AML and IoT, but future is depend upon totally IoT AML means it is we are necessary to study and understand AML, sir, for future understanding of vibration and condition monitoring.
It's not really that way. As I completely agree with Professor Abhijit regarding the AML is get us scared of because we are not. There are two aspects. One is a tool. AML is a statistical tool. Okay, right. We are not developing a new algorithms. Are you able to hear me?
Yes, sir. Yes, sir. I'm understanding, sir.
Yeah. So as part of our we studied the statistics, right? Our mathematics course, right? And also there are you will get to know how to do the regression is nothing but you try to do y equal to f of x, right?
Yes, sir. Yes, sir. Further transform.
No, y equal to f of x means there is a data is there. You try to create a function that will relate the input to the output in the form of function. That function may be the linear equation or non-linear equations, right?
Yes, sir. Yes, sir. Correct, sir.
So now what will happen is don't get scared that like it will become nerd. But and also another thing is that this moment is a data-driven approach, an opportunity, but it will not be eliminate the existing technology.
Okay, sir. Okay, sir.
Okay, so if you are inclined towards the statistics and you are trying to learn more like a design of experiments and analyzing the experiments with the data, then this will become as a complementary for your learning. And also, it's not very like a don't get scared that it is a computer science guys are doing that. Now, frankly speaking, acoustics is done by the electrical engineers.
Okay.
Okay, sir.
But we are studying for mechanical application.
Yes, sir. Yes. Why I am asking this question, sir, I searched so many papers and nowadays, so many research are done using that IoT and AML, sir.
That's true. It's like, see, always you want to publish, you need to start. Okay. So it's a different thing. Okay, I don't want to go there. As part of this FDP, what we are training, there is opportunity for the vibration. That is where we want to.
Okay, sir. Okay. Thank you, sir.
Thank you. Thank you.
Okay, now if there are no doubts, we request Dr. Abhijit Sarkar to take on the session.
Thank you very much.
Sir Venkatesham sir, thank you very much, sir. Now over to Dr. Abhijit Sarkar. Sir, good morning, sir.
Hi, good morning.
Good morning, sir. So first of all, let me introduce you to the participants, sir. Just a 1-minute introduction. Dr. Abhijit Sarkar is an associate professor in mechanical engineering in the Indian Institute of Technology, Madras. Dr. Abhijit Sarkar obtained his PhD from Indian Institute of Sciences, and his area of interest is mathematical formulation and analytical solutions of problems in dynamics and acoustics. Dr. Sarkar is holding rich industrial experience with Tata Motors and Aeon Technologies. And in today's session, Dr. Sarkar emphasized on the hands-on session for the beam vibrations using Python. Hope the participants can best make use of this one with your laptops and desktops ready for the session. So thank you, sir. Thank you all. Now, Dr. Sarkar, please take on the session, sir. Hello. Hello, sir. Am I audible, sir? Sir?
Sir, you are muted.
No.
Okay.
I was off from the internet for a.
Please.
Okay, sir. Okay, sir. Sir, can you take on the session, sir?
Sure, I will do that.
Thank you, sir. Thank you, sir.
Is my screen visible or?
Yes, sir. Yes, sir. Yes, sir. It is visible.
Okay. So, okay. Thank you. So first of all, my thanks to Vasavi Engineering College and
Professor sir, any issue? We are unable to hear you.
Sir?
I think you are in mute, sir.
No. He's unmuted.
Okay, I am looking like I'm having.
Please proceed.
Yeah. Now it is okay, sir.
Yeah. So at the outset, I would like to thank. Hello.
Yes, sir. Yes, sir.
Okay, maybe I'll switch off the video. That will help my internet.
Yes, maybe.
So
Right,
at the outset,
Right.
at the outset, I will like to thank the organizers for holding this faculty development program, and that too in the classical field of vibration and condition monitoring. So I wish them all the best, and thank you for giving me an opportunity to be a part of this program. I really hope that the participants get benefited from this program. So my part of the job is going to be, I will talk about computational issues, and just like since there was so much of interest about AI and ML, I am quite sure most of you have been awed by this onslaught that we have for Python. So I thought we'll introduce some exercises in Python in vibration. So that's the objective. So let me start by presenting my screen, and I hope this time it works. Is my screen visible to you?
Yes, sir. Yes, sir.
Great. Okay, and I'm actually new to Microsoft Teams. I usually use Google Meet, so maybe I'm also pressing some wrong button in a time. So anyway, I learned my way through. So yeah, so coming back to the objective of my talk. So what we are going to do is we are going to do symbolic computation for vibration problems. Yeah. So as I was saying that seeing in the previous session, there was a lot of interest about artificial intelligence and machine learning. And perhaps in this backdrop, you would realize that parallelly there has been a lot of, sort of talks around this Python. And somehow the notion is Python is the place to be for only AI and ML, and nothing else in this world will survive other than AI and ML. But I would like to, and more so, this has been our not only the mindset of the commoners, but our incoming students also tend to have this perception that Python is meant only for AI, ML, and data science types algorithms. But tell you what, Python, like any other computer programming language, is just suited to do many more things, including vibration. So I start with this comment that vibration is a classical field of study. I hope you can see my screen, right? Hello?
Yes, sir. Yes, sir. We are able to see, sir.
Okay, so the trouble is I get insecure at times that I have been knocked out of the internet. So please just let me give me some signs of life whenever I feel that insecurity.
Yes, sir. Thank you, sir. Okay, sir.
Okay. So just keep saying something, and you are most welcome to interrupt me during my talk. So if there is anything that you wish to interrupt me on, please feel free to do so. And that also gives me a feeling that I am alive, because I am very insecure about my internet. Already twice it has kicked me out. I hope it doesn't happen again. Anyway, so carrying on. So I begin my story this way, that the vibration has been a classical field of study. And I would like all of you to take pride in the fact that we are descendants of great people such as Newton and Euler and Lagrange and so on. So we have a very rich legacy. I would rather believe that computation is a relatively new kid on the block. Computer itself was invented in the 1950s. They have made massive improvements and massive strides. As it happens with any new technology, there is an immense growth which happens soon after the technology takes off. So computation is in that place, whereas mechanics or vibration is a sort of saturated field in the sense that it has been there for centuries, and therefore it's very difficult to, not that all problems have been solved. For example, turbulence still remains an open problem, and it will take, even the best of AI and ML people do get scared to try to understand turbulence. So don't tell me that AI and ML will solve everything. There will be problems in mechanics which are still unsolved, and the best of AI and ML algorithms will find it difficult to solve. So mechanical engineers will stay in business, just like Professor Venkatesham told you. So the point is, computation has, in the last 50 odd years, has gained immensely. And we have seen it in so many ways touch our lives, from the smartphone example that you have given us. And the very fact that we are doing this virtual meeting is a boon of computation and the developments associated with the computation. But we are not going to worry about those aspects of computation as to what technologies goes behind this online meeting, but rather we are all very aware of this numerical computation issue. So numerical computation is all pervasive and omnipresent in all fields of study, not just in computer science itself, but in everywhere else. And just like some participants were sort of feeling insecure as to what will happen to mechanical engineering as a stream. And today we see that mechanical engineering choice in the JEE ranks is far below the, let's say, computer science rank. But I tell you what we need to adapt as teachers is that we need to include computation as a part of our curriculum in mechanical engineering. So the vision is that every engineering will have computation plus its own core strength. So, the the curriculum as of today in various places is such that it is actually CS plus X. So everyone learns computer science to a certain extent. Together with it, mechanical engineers learns, mechanics, and they learn how to implement mechanics using computation. So that's how you will stay in business. You can no longer say that you will teach only mechanical engineering without computation. So mechanical engineering without computation is definitely not something which will attract any attention either from the industry or from the students. Computation has to be included in the curriculum, and this is something that I know that a lot of universities are lagging, but sooner than later we will have to change our curriculum and imbibe this spirit. And in fact, I am actually happy that in most mechanical engineering colleges we do teach courses like finite element method, finite volume method, even modern control systems. So all these are heavily computation oriented courses. So we have included computation as a part of our mechanical engineering courses, but probably we need to take it a few layers up. We have already done it in some way, but maybe we can do even better in the future. But the lament is elsewhere. So the lament is till now most people understand computation to be numerical computation where you do number crunching, which means if I give you a steel beam of 1 meter length and 10 centimeter diameter, you can find possibly its natural frequencies using finite element method. The flip side of this approach is that you don't know what would be the natural frequency of an aluminium beam of the same size. So every problem to you is different problem. So today, if you think that the beam problem is a stupid academic problem, I can give you another example. So let's say you are making a car with a certain sheet metal composition, and someone says that, okay, instead of using this steel, I will use that steel. The properties are different in such and such way. Now tell me how will the vibration change? How will the natural frequency change? How will the sound change? So if you wish to analyze this problem, the point is you have to do the entire simulation again for this new material, which can be very time consuming and can be very laborious exercise. So the idea is that this is something which is, I would call, a limitation of a numerical solution process. Numerical solution lacks insight. Whereas analytical solution, if I would give you a formula as to this is how the vibration of the beam is, then you can simply plug the appropriate values of its material properties and geometric properties, and then find the vibration for any beam, whether it is steel beam or aluminium beam or titanium beam, you can find its value. So in more ways than one, analytical solutions are very useful. And for some reason, especially after the advent of computation, we seem to have forgotten about this trade of ours, which is analytical solution. So analytical solution has its importance, but perhaps because of a multitude of reasons, we have seen that this analytical solution procedure has taken a backseat. And what I recommend is that we should have a balanced approach between the numerical and the analytical procedures. Usually all the finite element softwares that we are aware of and all the CFD softwares that we are aware of are mostly being used for numerical computation, though actually if you are very intelligent, you can non-dimensionalize things and extract even analytical or useful scaling laws out of these simulation softwares, but very rarely, and I say this with a lot of authority even for industrial practices, we have seen it's only numerical solution that is being used. In industries, it does make sense to look for numerical solution, because for industries, they are looking to solve a specific problem. But in academia, and especially for us as teachers, we are actually not interested in a specific problem. We are interested in the general problem. We wish to find out a formula which can tell us, which is applicable equally well for whether it is the vibration of an aircraft or vibration of an automobile. So therefore, analytical solution does hold its place under the sun. It is just that, most of the present curriculum has probably neglected analytical solutions. I will stop here for a moment. In case you have any questions associated with this paragraph, I'll take them. Any questions, please? I'm hearing a lot of noise from someone's mic.
Yeah.
Wait.
Yes, sir. We are muting, sir.
You can unmute yourself.
Yes, you can unmute, sir. You can unmute yourself, sir.
I muted, we muted all, sir. You please unmute yourself.
No, but at the same time, I wanted if anyone has a question, possibly he wanted to talk about. Yeah. Any questions?
Sir, you've been saying this, a balanced approach between numerical and analytical procedures.
Yes.
But even you take the industry perspective whenever we go into this numerical solutions. Obviously, it is very difficult to correlate between numerical and analytical procedures. So, can you be more specific on it?
Yes, what I'm saying is that we are not teaching our students analytical solutions.
Yes, sir.
If you are not teaching your students analytical solution, how will they go to the industry and make analytical solutions happen? Yeah. It is like, if we don't teach our student, how to talk in if we don't teach our kid how to talk in their mother language, they will never talk in their mother language. Yeah. So the same thing is happening. 100 years ago, when there was no computers, teachers were teaching analytical solution. And if you look up, old books, you will see lovely analytical solutions there. The first aircraft took off and the first, engine was made. So many developments happened without numerical computation. Yes. Where is all those happened because of useful analytical solution, because at that time there was no computers, they struggled and determined all those analytical solutions.
Yes, sir. Yes. Yes, you're absolutely right, sir. Right.
Hello, sir. Hello,
yes.
Sir.
Yes, please. Sir.
With all these technologies, everything happening in cloud, so we'll get the result, all right. But the traditional knowledge is being lost. What is your opinion? Already you have answered to some extent, but I think you understood what I am telling. Just we are interested only in result, yes, in an industrial perspective.
Am I audible?
Yes, sir.
Yeah, so as I was talking, 100 years ago, the first aeroplane flew because of analytical solution. It was not because of numerical solution. But somewhere down the line, we went overboard and we did everything numerically, simply because the industry was going that way. See, the industry comes later. First, there was someone who actually proved that yes, aeroplanes can fly, and for that to happen, you need analytical solution. So I am saying it is not necessary that that teachers have to be like only industry minded and teach only what industry wants. We have to go one step further beyond what the current need of the industry is. In industries, I understand analytical solution will not be useful, but we have to keep cultivating this analytical solution, because out of the 100 students that we are educating, one of those 100 students will become a Timoshenko. One of those 100 students will become a Von Karman, and they will need analytical solution, and it is these two students who will develop the society. The remaining 98 students will live and die, and they will, they will live happily in their life. But we cannot deprive our students to teach what is required, and that cannot happen simply because the industry today wants FEM and nothing else. Is my point clear to you, Mr. Anjanenu? So we have to go much beyond, beyond what industry wants. For placements, probably the only thing that is necessary is FEM. But the point is, we should not teach our students only for placements. We have to teach our students for the sake of knowledge, for the sake of education.
Yes, sir.
Right? We cannot simply throw away everything else in the back burner simply because it is not asked in the placement interviews. We have to teach what is asked in the placement interview, but we have to go a few steps beyond that also. And my lament is that we have somehow forgotten the importance of analytical solutions.
Yeah.
And that has happened simply because we feel that numerical simulation is perhaps easier than analytical solution. It requires less maths, and whatever is easy, it is a natural selection process that we will select whatever is easy for us. And we have taken the easier route. That's all I'm saying.
Yes, sir. Yes, sir.
Okay?
That's it. Okay, sir. Okay, sir. Go ahead, sir.
Anything else? Okay, fine.
Okay, sir.
So let's get to business now. So another comment before we make a deep dive. So as I said, vibration is a very old subject, and we usually have very classical books written, and we teach from classical books such as Thomson's, Meyerowitz, and S.S. Rao. But very important thing to note is most of these books were written before the advent of computation era. So a lot of analytical solutions that are given in these books actually appeared before the advent of computational era. But we can understand that analytical solutions have its own, difficulties, and mostly they are vulnerable to human error. So if you make some sign mistake here and there, you will not get the correct answer. So a midway approach that has now evolved is that even these analytical calculations can be done in a computational environment, and that is what is called symbolic computation, or what is called a computer algebra system. In my experience, I believe not many places emphasize this approach. Usually computation means numerical computation, but I hope that in my talk I will sort of emphasize this aspect to you. So this is what would substitute the pen and paper approach. So instead of doing the pen and paper symbolic calculations, you could as well do it using symbolic computation. So what we will do is that as teachers, what we need to do is that we need to popularize this symbolic computation approach to our students, and hopefully one of them or two of them will pick it up and will contribute to analytical solutions which will be useful in developing our field. Perhaps I agree that symbolic computation doesn't probably find a place in industrial practices as of today, and I don't see that happening to be happening in hardcore mechanical industries right now. But none the same, I hope I have convinced you that for the sake of our own field, for the sake of academics, we have to popularize this approach, and we have to introduce it. We have to put it on a plate and serve it to our students. Some of them will like it and will pick it up and will take it forward, and they will be our flag bearers. So we should not deprive our students to have this choice, because only if we introduce this to our students, only then they will be able to take it off. Some students are happily oblivious that there exists something like symbolic computation. So that is my passionate appeal to you, that you should introduce such exercises within your curriculum at your respective places. So now, what is the tool of symbolic computation? There are many tools. Python I have selected for a different reason, because two reasons probably. Python firstly is a freeware. Octave is also a freeware, but perhaps Octave has not got so much popularity as Python is. Everywhere you go, people wants to know whether the students have learned Python. So this is one way in which you can sort of swim with the tide, and you can use it to your own advantage. So within Python, if you are aware, there are many modules. NumPy is the module associated with the numerical computation. SymPy is the module associated with the symbolic computation. So we shall be using SymPy today in today's demonstration. Then there is MATLAB. MATLAB and Mathematica both are actually proprietary softwares. You need to pay out of your pocket to use them. Otherwise, it's a very good tool. But I would think the freeware is also as good as the the one which is chargeable. So anything that you can do in Python, you could also do it in MATLAB. At least the demonstrations here is quite possible. The only reason why I did not choose to use MATLAB is that it is not a freeware, and therefore possibly some of you may have difficulty in accessing MATLAB. So Python and Octave are freeware, and therefore students are passionate to learn these tools and packages, and it gives them an edge in pre-placement and placement interviews. So therefore, it does make sense for the students to have an eye as to how they can use these computational packages and put it on their CV so that they can get good job offers. So all that I'm saying to you is that we can incorporate these sort of activities in our existing curriculum, so that it's a win-win situation both for the students as well as for us. For the students, as I said, it gives them an opportunity to put these skills on their CV and catch the eye of an employer, and hopefully land up in the best jobs. And similarly, we know for our own sake, we need to develop this field and we need to use analytical solutions. So as I am going to demonstrate, instead of pen and paper calculation, you can use these computational symbolic computation packages such as SymPy to do our reasonably complicated problems. So that's what I have to offer you in the next 1.5 hours or so. So with that little introduction, we'll actually go for a deep dive now. Before we do, again, another, let's say, a minute's break, so that if you have any questions, you can shoot it to me. And also that gives me a chance to know whether I am still on the internet or have I been thrown out.
Yes.
Anything?
Any questions from the participants?
Screen is not shared, sir, as of now.
Oh, screen is not shared. You should have told me.
Yes, sir. Yes, sir.
But the solution was very clear. Okay.
Okay. Since I was thrown out, I forgot to share the screen. Is the screen shared now?
Now it is okay, sir. Now it is okay, sir.
Okay. Okay. Shall we go ahead?
Yes, sir. Yes.
Okay, so let's we thought of doing two problems. One is to determine the natural frequency and mode shapes of the beam. So let me give you the background. So the governing equations for the beam, as you know, is this one. I hope you are able to see the highlighted portion. It is EI, which is the flexural rigidity of the beam, multiplied by d4v dx4 equals to W. V is the deformation which we are interested in, and Wx is the load intensity. So this is the usual actually statics equation. You can convert the statics problem into a dynamics problem by including the inertia force. So once you include the inertia force, the free vibration equation becomes in this sort. So the point is we need to solve this equation. So we will look to solve this equation by assuming, or we will look to find what we call a single frequency solution or a harmonic solution. So we may go ahead with a bold assumption that this V, which is a function of both x and t, the double dot actually means it's a time derivative, 2 times time derivative. So we are saying that the time part of it, the time function, the temporal function is varying in the sinusoidal or cosinusoidal fashion. So this is how we are making an assumption. If we are indeed able to find a particular omega and a particular Vx, which conforms to this form, then our assumption will be validated. So at this stage, we are taking a leap of faith and we are saying that let's hope that we are able to find this solution. And when we will be able to find an omega and Vx, we will pat ourselves on the back saying that yes, we have found it and therefore our assumption is valid. So once you plug in this assumption into this equation, so what you will see is that you will get a double derivative with respect to time, which pulls out the minus omega squared term. So therefore the minus here becomes plus, and you are left with an ordinary differential equation. This is a partial differential equation. This is an ordinary differential equation. And the above is actually the most elementary ordinary differential equation. It is called linear constant coefficient ordinary differential equation. So our usual engineering maths tells us that we can have different solutions for this ordinary differential equation, and it so happens that the eigenfunctions of the differentiation operation are the exponential functions, or maybe you should say here the trigonometric functions. So the trigonometric functions, if you just plug it back in, you will see that this equation is getting satisfied, which means the general solution of this equation must be of this form. Okay, so this is the general solution of the free vibration problem. The only unknown that we are still to find out is these constants A, B, C, and D. So please remember, this Vx is the general solution of the differential equation. The only issue is we need to find out the appropriate value of k, which obviously depends upon omega. So instead of omega, we have transformed our variable to k, and the constants A, B, C, and D needs to be found. Okay, any questions till this point? Any questions?
No, sir, you can go ahead, sir.
Okay, no, the reason why I'm taking a break is also to find out whether I am on the internet, because
yes, sir.
It looks very idiotic for me that I keep on talking and then I realize that I have been thrown out of the internet. Okay.
The screen is disappearing, sir, sometimes. That's the only problem.
I really don't know. I have shared my screen and that's the best I could do.
Okay,
and I
sir.
have also switched off my camera, so
Yeah,
I am
yeah.
not consuming any extra bandwidth.
Right, sir.
So only during the break, sir. Only during the break, I think.
Yeah,
Only
yeah.
during
Only
the
during the break. Yeah, yeah. That's it.
Yeah. So just before I am thrown out of the internet, those technical issues are happening, but
Okay,
I
sir.
hope let's
Yeah,
go
yeah.
ahead.
Okay, sir.
Okay, so then next we'll do a little trick. Since, as I said, that in an analytical solution procedure, we are not really interested to solve a problem. We are interested to solve the general problem. What is the difference between a specific problem and the general problem? A specific problem means that you would be interested to solve, let's say, a beam of only length 1 meter or 2 meter or half a meter. Whereas in a general problem, you would say that, okay, I should be able to find the natural frequencies of any beam. So to do that, one very good idea is to non-dimensionalize it. And again, just to emphasize how important this idea of non-dimensionalization is, I would recollect the story of turbulence and Reynolds. So if I tell you what is the criteria at which the flow becomes turbulent, then you will recall that Reynolds number tells you that whenever the flow is such that the Reynolds number is something like 2100 or so, then the flow has become turbulent. That means whether you have water in the pipe or whether you have gas in the pipe, whether the pipe diameter is 1 inch or 2 inch, it doesn't matter. As long as that non-dimensional group of number is calculated to be 2100, then the flow which is happening through the pipe has transition to turbulence. So therefore you see that the criteria that we are giving is in terms of a non-dimensional number, and that enables you really to go far beyond, a one problem situation. If Reynolds obviously did his experiments with a pipe filled with water and found out that 2100 does hold, but then he never said that this is the condition at which the pipe flow, water flow through pipe is becoming turbulent. He extracted a general condition, and he did say that, once you have this condition satisfied in any fluid in any pipe diameter, then this condition will be satisfied. The condition of turbulence will kick in. So a similar situation we should do for any physics-based problem. You should try to non-dimensionalize. Another good example where people still now give a lot of value to non-dimensionalization is your heat transfer. Again, if you recall your heat transfer class, you evolve various non-dimensional numbers such as Prandtl number, Nusselt number, Grashof number, etc. So, for example, in forced convection, your entire deal is to relate Nusselt number as a function of Reynolds number and Prandtl number. So the idea again is you should be able to extend your theoretical answer not just to a one fluid, one geometry type of problem, but to any fluid, any geometry. Within that framework, it should be applicable. So with that little lead, I will say that I would like to non-dimensionalize this solution. So therefore, I am evolving a non-dimensional parameter, which I am calling xi, which is x by L. And instead of k, I am evolving a non-dimensional parameter kappa, which I am calling is k times L. Remember, k has units, but the units of k, if you work it out, you will see is 1 by length. So k times L will be non-dimensional or unitless. Similarly, xi, which is x by L, will be unitless. So k times x is same as kappa times xi. So I have just replaced k times x to kappa times xi in the previous expression. And after that, the entire story is we need to find out A, B, C, and D. So here I will now start my hands-on demonstration part with the Python. So towards that, if you wish to do it parallelly with me, then the first step is go to Google and search on with Jupyter Online. Okay. Is everyone with me? Jupyter Online is what you should search with. So, Arey Bapre, what has happened? No, this doesn't have a traffic light. Yes. So go to this project Jupyter. Can someone tell me whether it's working at their end? Hello?
Yes, sir. Yes.
So when you go to this jupyter.org/try, then you will see different these things. So you can try the classic notebook. Okay, try classic notebook. Try classic notebook. So that should open up in a moment. The advantage of online compilers is that you don't have to download anything, and especially in Python, sometimes installations can be troublesome. So it's better to use online compilers because everything is available in the online system. You don't have to download anything. All modules are available. So you should be able to get to a screen which looks like this. How many of you have got? Can we have a quick on the chat? Please tell me whether you have got to the screen that I showed you. So I am in this screen. So in the chat box, please write those who have been able to get to this point. The organizers, is the chat enabled for the participants?
It is there, sir. It is enabled.
Yeah. So can the participants please type in the chat box whether they are able to arrive at this page as I am showing? Hello, am I back? Am I back?
Yes, sir.
Okay. Is my screen visible? Is my screen visible? Can someone tell me?
The participants are visible, sir, in your screen.
Yeah. So,
Yes, sir, it is visible, sir.
okay. So can I assume that participants have been able to land up into this screen? Any participant having any problem?
Yes, sir. Now
Okay, very good.
It's visible, sir.
Okay, so please go to File, New Notebook, and Python 3. File,
Okay,
New
sir.
Notebook, and Python 3 is what you need to go to. Okay. So when you do that, a new tab will open in your browser, and you are
Yes, sir.
ready to run Python. Okay. So
Okay, sir.
yeah, maybe one of you can just let me know whether things are working correctly at your end.
Yeah, working, sir. Able to open Python 3.
Very good. Okay. Okay. So let me just give you a brief as to how this works. So this is the cell where you can type in the commands, whatever you want. Okay. And please make sure that this is in the code mode. It should not be in the markdown mode or any other mode. It should be in the code mode. So we will not tamper with this. So what you have seen here is that I have actually made this file. So some part of it is marked down, which is in this fancy text. Other part of it is in the code mode. So this is the code mode of it. And we are only going to write the codes of it. We are not going to write these elaborate comments as a part of our hands-on demonstration. So we will start our hands-on session here. So the first command that we will write is about importing the module. So let me go one by one. You can please type in one after the other as you're seeing my screen. Okay, so let's walk you through with these commands. So import SymPy means that you are importing the symbolic computation module from Python. As I said, the symbolic computation module is called SymPy. The next module is that I am importing is NumPy. So NumPy is the numerical computation module, and I am importing NumPy as NP. So NP is an alias to NumPy, and you will be incorporating all the functions from NumPy through this shorthand name of NP. And similarly for plotting, we need this function matlab.pyplot. So we will import matplotlib.pyplot as PLT. So you have to import this one also. And we'll need some algorithms which will come from the SciPy module, which is called the scientific computation module. So from SymPy, we have to import lineage and optimize. So these are the four things that we need to import. So if you can please type in this matter into your into the code cell, that will be great. I have already written it, so I will copy and paste in the code cell, and hopefully that will work. So when you see it start, that means it was still running. When you see this number 1, that means the that these commands have already been executed. So you are ready to type in more commands. Any questions till this point? No, is everyone able to follow till this point, or any issues have cropped up?
No.
Okay, very good. So let's move forward then. So the next one is that we have to define the symbol. So it is like those of you who have done Fortran or C earlier, in you have to define the variable. So unlike in a numerical computation environment in Python or MATLAB, which is dynamically typed, that means you don't have to define the variables. All symbols, again, this is true even in MATLAB also. If you are defining symbolic variables, you will have to define it. One issue that you will have to keep remembering is that if you are defining one variable at a time, you have to use capital S in symbol. And if you are defining multiple variables at a time, then you have to use symbols and with a plural S, and the opening is with a small letter S. So this is what defines the symbol. So I will again copy this and paste it in my online compiler so that it runs. So here, by the way, the running is, after you copy and paste, you have to hit Shift Enter. So Shift Enter will make it run. Whereas if you wish to go to the next line, you will, within a cell, you have to press Enter. So that's how you go from cell to cell or from line to line. If you wish to go from line to line within a cell, simple Enter will work. If you wish to go from one cell to the other, you have to hit Shift Enter or take your cursor and go. The way you will realize that the program has executed or the instruction has executed is by noting these numbers in the square bracket. So if the number has changed is 1, that means this is the first set of instructions which Python has executed. And when I am seeing the number 2 here, it means it is the second set of instruction which Python has executed. I will again pause here for a moment just to ensure that you are in sync with me, I will also zoom it up so that my screen is very visible. Any questions? Any questions?
Yes, sir. You can proceed to the next step, sir. It seems.
Are the participants working it out? See, there are two situations when questions don't arise. One is when you understand everything, and the other is when you don't understand anything. Okay? And I would think that usually it is the latter than the former. So if there are no questions, I am assuming participants have already dropped off. Any questions?
Not sir, we are following.
Huh? Kiran Kumar?
We are following, sir. First part we have done, but variables we are defining, sir.
Okay, yeah, so I'll wait. See, this is supposed to be an online session. You should be in sync with me, because if I directly start dumping you all the code, which is already written in my computer, then I will go fast and you will lag. I don't want that to happen. So please write whatever is written in my screen, and please ensure you don't get any, any error messages when you hit enter. If you make some spelling mistake or something like that, you will get some error message. So I'm leaving the screen in this part so that you can see what I have typed. You should type identical things.
Sir.
Begin చేశాను ఫార్మేషన్ ఆఫ్ సాఫ్ట్వేర్స్ గవర్నింగ్ ఈక్వేషన్స్ చెప్పాను ప్యానల్ మీద రిలేషన్ బిగిన్ చేయాలి.
Okay, is everyone done till this much? Can I proceed?
Yeah, okay, sir.
Okay, fine. So let's go to the next group of commands. So what I will do is that I will code up this part. So I need to define this deformation as I have written in this formula. So that simply means that I have to call the sine function, cosine function, sine hyperbolic function, and cosine hyperbolic function. Please understand, kappa and xi has already been defined. So the one trick that you have to remember is that the sine function is the part of the SymPy module. So to call it, you need to put SymPy.sine. Similarly, the cos function is a function within the SymPy module. So to call it, you need to put SymPy.cos. So that is the way in which the object-oriented framework of Python goes. So you'll have to use this dot. So what I'll do is I will cut and paste this entire stuff, bring it here and walk you through. So the first statement here, it is simply defining the function v, and v is a function of xi. So it is defined in this fashion, which is basically a times sine kappa xi plus b times cos kappa xi plus c times sine hyperbolic kappa xi, and finally d times cos hyperbolic kappa xi. Okay, so just I have typed it in, typed in the function the way I have written it. And in the next step, what I have done is that I have differentiated this function with respect to xi. So this is what I have defined it as VD, D standing for differentiation. So to differentiate it, I can actually use the diff function. It is a part of the SymPy module. So again, following the same rules, I see that I have simpy.diff, which means I need to differentiate this v as a function of xi. So that is the second line of this cell. And similarly, the third line is the second derivative, which means whatever is the first derivative, I do the differentiation once more and get at the second derivative. And again, whatever is the second derivative, I get the differentiation once more and get the third derivative. So please type in this part of the code in your laptops, so that we are in sync, and I'll give you a few minutes for that. And by then, if you have anything to discuss, we can discuss it also.
Praveen sir, your mic is on.
Is everything done? Any problems?
First, Vishwanathan sir, you are on.
Can we stop this crosstalk, please? There's a lot of crosstalk happening. I think everyone other than the organizers probably should work only on this. There's nothing else more important to you at this point of time. Can we stop this crosstalk? Mr. Kashi Vishwanathan, can you please stop the crosstalk? Mr. Kashi Vishwanathan, can you hear me? We go ahead from here. Kiran Kumar, are you talking something?
No, sir, just I'm confirming that we have done it.
You have done it?
Yes.
Okay, very good. No issues, is it?
Okay, no.
Okay. So let's hope you have come till this stage, and just if you wish to see what are these expressions and verify whether they are indeed the ones you wanted, you can echo these expressions. If you type V and press Shift Enter, you will see the expression for V. And similarly, if you type VD, you will see the expressions for the derivative of V. And if you type VDD, you will see the expression for the second derivative. And if you type VDDD and hit Shift Enter, you will be able to get the exact derivative expressions. So I hope you, at this stage, you will realize that it is how symbolic computation is helping you. you are able to compute the derivatives of this function effortlessly, and all of this is robust, and it is not prone to any human error. In human, when you do it in pen and paper, depending upon your mental state, you may commit some mistakes, but this is very robust. Here there is no chance of making any mistakes. So I hope you have verified this step. If not, let me know. Anyone wants me to wait for a while? Anyone? Okay, I assume everyone is with me. So what we'll do is first we'll attempt the simply supported boundary condition. So for the simply supported boundary condition, we should have 4 equations. The 4 equations are as follows. At the 2 endpoints, you must have displacement to be 0. To invoke that boundary condition, what we are going to do is, in the expression for V, we are going to substitute xi equals to 0. That's precisely what that first line means. So the first line here means that I am asking Python to substitute xi equals to 0 in the expression for V. And similarly, in the second line, I am asking Python to recall the expression for V, and within that make the substitution xi equals to 1, and whatever is the resultant is assigned to this variable equation 2. So please understand, this only implies the left hand side of the equation. The right hand side of the equation is 0. We don't explicitly write that, but we have it in our head that the right hand side is 0. Similarly, the boundary condition associated with the moment, because it is simply supported, the moments have also got to be 0. So the moments conditions are associated with the second derivative. So the second derivative expression, whatever you calculated, that in that you are going to substitute xi equals to 0. Please understand, since we have changed from the dimensional x variable, which goes from 0 to L, we have changed it from the dimensional x variable to the non-dimensional xi variable. So x, instead of going from 0 to L, we now non-dimensionalize it, and we are assuming that xi is going from 0 to 1, because after all, xi is defined as x by L. So with that, you should see that you have to substitute xi equals to 1 for the right hand side of the boundary condition. So here again, the moment condition, which is equivalent to the second derivative of V, in that expression xi has been substituted as 1, and the resulting expression is called equation 4. So this is what this block of code does. I will again copy and paste it in my online system here. So with that, my equation should have been formulated. So I'll give you some time to write down these equations again in your own system. And if during this time you have any doubts, you can raise it to me. The objective is that right within this 1.5 hours session, you should be able to at least work out one problem by yourself, and hopefully that will give you a kickstart, and you should be able to do other problems by yourself and take home this message. So please don't think that you want to do it later on and all these things, because later on you will get into difficulties, and then I will not be available to you to resolve those difficulties. How many of you are seriously doing? Can we have a quick count? Yes, Kiran Kumar, please go ahead.
No,
Ask
sir,
what you want to.
Yeah, I completed.
Kiran Kumar has completed. Anyone waited? Still awaiting? Okay, let's go ahead then. So we have formulated our equation. Yeah, I think this is working. Just let me see. Yeah, this is fine. So let's go to the next group of equations. So this group is for cantilever, so we'll change it later. So we will make a matrix out of I mean, the way we will solve this equation is that we need to find the unknowns A, B, C, and D. And remember, it's a free vibration problem, so it's a homogeneous set of equation. So we will like to solve these 4 equations, not only for A, B, C, and D, but also the in terms of K. So this K or kappa rather, we need to find it out. So we'll have to construct a matrix. So the matrix is basically, I hope you can see my screen. So we wish to construct a matrix M, which depends on this non-dimensional number kappa, and the variables are unknown variables are A, B, C, and D. And on the right hand side, as I said, each of these terms are 0. So we know that the non-trivial solution for this homogeneous equation is possible only if the determinant of M, which is a function of kappa, is equal to 0. So this will let us actually find kappa. Okay. So at this stage, we need to construct this M matrix so that we are able to set up our problem correctly. So with that being the objective, we are firstly initializing this matrix to be numbers of zeros, 4 by 4 matrix, because we have 4 variables, as I just wrote here, A, B, C, and D, and also 4 equations. So this matrix M has to be a 4 by 4 matrix. So the first line initializes them to be 0. Within this loop, we are going to change it. So the second line, what it does is that it collects all the unknown coefficients, puts it in the form of an array or a vector. So the vector that I have written here is now constructed, and this I am calling it as S. And this S array is having 4 elements, which are the unknowns A, B, C, and D. And similarly, the equations 1, 2, 3, and 4, I have put them in a group, and I have called it the array of equation. So what I am now doing is that I am stepping through 2 loops, and from each equation I am taking out the coefficients one by one. So let's say first I am going to equation 1 and extracting the coefficient associated with the first element of this S array, and whatever is that value, I am storing it in the appropriate element of the matrix M. So in this fashion, when I repeat it 4 times, I should be able to rewrite the appropriate entries for M, and at this stage, therefore, my matrix M would have been correctly constructed. Is this step clear? Is this step clear, or there are any questions?
Just 1 second, sir. We are just typing that. Just 1 second. Sir.
Okay, please type it.
Can you just
one thing is you have to type whatever I am saying, and the second thing is that you also need to understand it. You have to keep your brains open, as well as your hands and fingers should also be active. So you have to understand what we are doing, and you also need to do or repeat what I have already done, so as to ensure that you are doing it correctly. Yes, please go ahead. Someone was talking something.
Sir, can you brief once again, sir?
So which part, the theory part or the implementation part?
Yeah, implementation part, sir.
This part you understood, right?
Yes, sir.
Okay. So the point is, I need to construct, see, in a computer, you need to implement whatever you are writing in your notebook. The computer can't do anything more fancy than what you have thought. Okay. So I want to construct this matrix equation where the variables are A, B, C, D, and the entries of this matrix are dependent on this term kappa. So how do I construct this matrix? So this first step is simply initializing this matrix as a number of zeros, and within bracket 4 means it is a 4 by 4 matrix. I am telling SymPy that construct a 4 by 4 matrix with all elements as zeros. Obviously, the real matrix with which I will work with is not a matrix of zeros, but then I will rewrite these entries of the matrix appropriately in due time. But to initialize it, to start with, I have put it as zeros. Is there any problem associated with this logic? Is this clear? Okay.
Clear.
The second line, what it does is that it collects this A, B, C, D, which I had defined here. This A, B, C, D, all these symbols. It simply collects all these and puts it in a container or in a box, which is an array. So I am constructing an array because an array is an equivalent of a vector. Okay, so this is a vector, and in this vector I have 4 elements A, B, C, and D. So this is the syntax by which I can define a symbolic vector in which I have the numbers A, B, or rather the symbols A, B, C, and D. So this is a symbolic vector as opposed to a numerical array or a numerical vector. Any questions with this one? Any questions with this one? Is that clear? Can you please respond? Okay. And similarly, the last one I have in this third line, what I have done is all these equations which I had written, I am again storing it in the form. So this is the left hand side part of the equation. The right hand side, as I said, is 0. The left hand side of all these equations, I am collecting it in an array which I am calling it as an equation, as EQ. Now I have to appropriately rewrite the values of M. So if let me take equation 1 and show to you what I am actually doing. So if I say equation 1, I will get what equation 1 is. So equation 1 is B plus D. Okay. So equation 1, as I have showed to you, is B plus D. So if I have to write this in a matrix form, so what do I have to do? So the first row of the matrix M should give me the equation B plus D equals to 0, right? So the way to get it is that now I am constructing only the first row of this matrix M. Okay. So what should be this entry? The first entry, 1, 1 entry. What should be M11? What should be M12? What should be M13? And what should be M14? Can someone tell me?
First one is 0, right, sir?
First one will be 0 because there is no A. The second one will be 1 because B gets multiplied with 1. And similarly, the third one is 0. And similarly, the fourth one is 1 because D gets multiplied in 1. So how did we find this to be 1 and 1? We simply noted what is the coefficient multiplying B here. And we noted what is the coefficient multiplying D here. And how did we calculate what is that this is 0? Because we said that this is equivalently 0 multiplied by A and 0 multiplied by C. So to get the first row out, all that we need to do is take the first equation and look at the coefficient of A, look at the coefficient of B, look at the coefficient of C, and look at the coefficient of D. Whatever these coefficients are, we find them out and store it in their appropriate places. That's all it takes to construct the first row. Now if we have to construct the second row, you have to repeat the same process with the second equation. If you want to construct the third row, you have to repeat the same process with the third equation. And if you have to repeat it for the fourth row, the fourth equation has to be constructed in the same fashion. Is the explanation clear? So this is exactly what I have done within this loop. So first I am going in terms of equations. The outer loop is in terms of equations. So each time I am looking at one equation and finding the coefficients associated with this S matrix within this equation, and whatever are these coefficients, I am storing it in my M matrix. Is the explanation clear this time?
Yes, sir.
Yeah.
Okay, are we done till this step?
Yes, sir.
Okay, let's go ahead. So this is done. If you want to admire the M matrix, or if you want to just cross check, this is the M matrix that we have now constructed. Now, how many of you think that you can find the determinant of this matrix by hand calculation? That's very difficult. So we should not try to do that by hand calculation. We should employ the power of symbolic computation or computer algebra system. So what we will do is, the command to find the determinant is det. Within SymPy, we will call the function det. So that's what the first line says. The second line is, okay, I need to talk a little bit here. So what happens at this stage is that this is in symbolic form. I now need to convert this into a numerical form, because finally I need to get the number out rather than the formula out. So let me show you what's the difference. So if I leave it in this form, then I do get an expression of this form. But I cannot use this expression for plotting, because if you look at what data type it is, it will tell you that it is in symbolic form. It is in, where it is showing, it is in a form which is compatible with SymPy, which means it is in symbolic form. So what I have done in the next statement is that I have converted this into a numerical form. And the command to do that is lambdify. So sympy.lambdify converts this into a numerical form. So I can now show you that it has been converted to a numerical form. So now if I look at the data type of this new creature, det_m_num, so this is just the numerical implementation of that symbolic expression. So now you will see that it is a function. It is no longer showing me that it is a SymPy object. It is rather a numerical function which I can use in numerical computation. So please type in these two cells at your respective in your respective computers, and then we'll go ahead. Any questions? Please shoot it at me. We have about 15 more minutes. Hopefully we can do at least this example and then take up some questions again. Any questions? Any questions? Any questions? Are we done till this point?
Yes, sir.
Okay. So now what we have to do, as I told you, is that we have to check at what value of kappa is this determinant equal to 0. So the easiest way to do that is just plot this determinant function as a function of kappa and check at what value of kappa does it cross 0. So to do that, it's very easy, because you already have it in the numerical form now, which is in this det_m_num. So what we have done here is that we have now constructed a new numerical vector. This is NP, that means it's numerical. So what I will do is I will bring this here in the online compiler and demonstrate to you. So this k vector, let's say I will call it that between 3 to 4, I have divided in 100 parts, and this k vector is constructed. So it consists of 100 elements between 3 and 4. So linspace command is just like the way you have it in MATLAB. There's no difference. But since it's a part of NP, so you have to call it as np.linspace. And then I plot this vector, which is the x-axis is this vector, and the y-axis is this determinant computed at each and every value of this vector. And then I will see how it looks like. So this is how it looks like. And it is evident that there is a zero crossing that is happening somewhere here. And to make it even better, I will show it in a zoomed form between 3 to 3.5. So if you see carefully, between 3 to 3.1, the function is positive, whereas between 3.2 onwards, it is negative, which means there is a zero crossing that has happened somewhere here, which is between 3.1 to 3.2. So we have identified that there is a zero crossing that has happened, and therefore that is the approximate location of the route, but we'll find a more exact location. To get at the more exact location, you need to know the approximate location, and looking at this graph, we will get the approximate location. So please key in this group of commands, and then again we will go ahead. And one of you please give me a message that it has been done so that we can move ahead. I hope I am still alive on the internet. Yes.
Yes, sir. No problem, sir.
See, I think what has worked for me is that I am this time using from my browser. I did a mess of things by actually downloading Microsoft Teams and joining from the app.
Yes, sir.
But looks like the browser is more stable than the app.
Ah, yes, that's it.
So it has, finger crossed, never disconnected from the browser once I joined from the browser. Very strange things happen.
Ah.
And that too from Google Chrome browser. That's interesting.
Yes, sir.
So Microsoft should be used from Google Chrome browser.
Ah.
Great. Okay, can someone please message me that we can move ahead? Oh, I need to be here. Yeah. So you need to type in this group of commands. Are we done? Can someone please say whether we should proceed or? Can someone please say whether we should proceed?
Yes, sir. Completed, sir.
Okay, very good. So in the next step, what we'll do is that we will actually determine the exact route. So let me copy this here in the online system. And so our approximate route is somewhere near 3. So we'll let Python know that we are expecting a route near 3. And the command to determine the route is optimize.Newton. So if you look back, we had imported this optimize routine. So since we have used import, we need not call SciPy again. So from SciPy, which is a bunch of larger package, we have imported only lineage and optimize. So this optimize is what we are using now to solve for the exact route. Within optimization, there are different methods, and Newton's method is supposed to be one of the more robust methods. So we are using Newton. So therefore, we are using this command optimize.Newton, and then we will have to give the function which we are trying to optimize, which is det_mnum. So det_mnum is what we are optimizing, and the approximate value of this route, we have to pass it on as input, which is what we have written here. As the output of this, we will get the exact solution. So the exact solution will get printed in the next line through this command. If you want it to be printed, it's fine, else it's okay. Even if you don't print it out, you can just echo it using ksol. This is just an optional statement if you wish to do it. So I am entering, executing this group of command. So you should be able to see now that the exact root is calculated in this fashion. This, by the way, is what is known as pi. So we have actually got our root at pi, which is very fine. So I would let you give you some time to write the first two commands in this block. The third command need not be typed. It is just optional. If you have time, type it. If you don't have time, forget it. Are we done? Please let me know if you have any issues. Can we move ahead?
Yes, sir.
Okay, very good. Okay, so now this is the exact root that we have found out. So we now need to look to find the I mean, actually this is the natural frequency. So we were trying to find a value of kappa for which the solution exists. So it has now been at this stage what we have found that kappa equals to 3.14, or rather pi is the solution. And remember, kappa was given as fourth root of rho a divided by ei into omega square, which means the square root omega equals to pi. So therefore the natural frequency can now be found out as let's say pi square multiplied by square root ei divided by rho a. So we have actually found out the I forgot the L. So kappa is actually KL. So this should be multiplied by L, which means this should be divided by L. And I have forgotten to take the square of it. So this has to be squared. Okay. So this is now the formula for the natural frequency, the first natural frequency. So I hope you have attained the objective. Now what I wanted to show you really fast, and maybe this one you need not do it at your end, but you can just look at my demonstration. What is the need to make this struggle? The struggle will pay off in the following fashion. Now, if I say that instead of the first natural frequency, I am looking at the second natural frequency I wish to find out. So again, I have to repeat the same procedure, but the determinant is as it is. So therefore, all that I need to find is to find a new root for this determinant, which is beyond 3. So let me try at, let's say, 6, between 6 to 7, and see whether there is a root that is there. So between 6 and 7, again, I should yeah, between 6 and 7, if I look carefully, or I'll just point between 5.5 to 6.5. If I look carefully, I will see that there is another zero crossing that has happened. Between 5.5 to 6, I am seeing it's negative, and beyond 6.2, I am seeing it is positive, which means there is, I mean, somewhere here there is a zero crossing, which is just beyond 6.2. So this graph again enables me to find out where the zero crossing has taken place, and therefore that is another root. So now if I repeat the same procedure with the approximate value, which is somewhere near 6.2, I should be able to find the approximate root as 6.2x, which is 2 pi. So therefore the second natural frequency is at 2 pi, and you can keep doing this for other natural frequencies also. So if I wish to change my problem, it is so very easy to do it. Secondly, if now instead of a simply supported beam, I wish to solve for let's say a cantilever beam. So just to make sure that my variables don't don't conflict with the previous variable, I will restart and clear output, and I will rerun this same code again with a changed boundary condition. So the first block is as it is, I don't need to worry. The second block is as it is, I don't need to worry. The third block is as it is, I don't need to worry. Only thing which will happen is that there will be a change in the boundary condition. So this time the changed boundary condition will be as follows: at x at xi equals to 0, the v is 0, and also at xi equals to 0, the rotation is 0. So the first two equations is taking care of the fact that the deformation and the first derivative is equals to 0. The second two equations should take care of the fact that the shear force and the moment is 0. So the second derivative and the third derivative should be 0. So these equations have thus been reformulated. So these equations are as follows. Again, I construct the M matrix as usual. The M matrix is constructed. This is my M matrix. The determinant gets constructed. The numerical value of determinant gets constructed. And again, this time I have to look for solutions. So let me try something between 3 to, let's say, 8 and hope that there is a solution. So if I see the value between 3 to 8, something strange is happening. And there is definitely a crossing that is happening between 7 and 8. So if I look carefully now, between 7 and 8, there will be a crossing for sure. And again, you see there is a crossing at 7.6. Sorry, at somewhere here, 7.8. So this part is positive, this part is negative. So therefore, I am quite sure that near about 7.8, there is a route that is applicable. So again, if I make an approximation that the route lies at 7.8, I should be able to find the exact value of the route. So this is the exact value of the route, and this conforms to one of its natural frequencies. But we need to check whether it's the first one or there is a route before that. So we'll do that later perhaps. But what I want you to take home from this exercise is that it is so easy to make changes and have a common code that will be applicable for simply supported as well as cantilever boundary conditions. If you have tried to solve the cantilever boundary condition through hand calculations, you will realize it is extremely difficult to do so. But here it is quite easy in this symbolic computation framework. The next part of the demonstration, which I will simply do it here, but maybe you don't have time to implement it. In the next part of the demonstration, what I have implemented is that once this eigenvalues have, once this natural frequency is calculated, we need to find out these A, B, C, and D's. So the way we are finding it out is that we are finding it out as the eigenvector associated with the zero eigenvalue. So once this kappa is found, then we find out the eigenvectors associated with, we find out once this root is found, we substitute this value of root in the appropriate expression and then convert it into a numerical array of matrix so that we can use the numerical algorithms to find its eigenvalues. And in this line, we calculate all its eigenvalues and all its eigenvectors, and then note at which eigenvalue the eigenvalue is minimum, and then we extract the eigenvectors associated with the minimum eigenvalue, which is near 0, and whatever are these numbers, we substitute them in the expression for V. So instead of A, we are putting AN, which is the eigenvector, and similarly B is substituted with BN, C is substituted with CN, D is substituted with DN, and kappa as usual is substituted with K sub. And once you do that, this symbolic expression is completely determined, and then you can lambdify it, which means you convert the symbolic expression to numerical expression, and then finally plot it to admire the mode shape of the beam. So that's how the mode shapes can also be done. Unfortunately, the time was not permissible for you to do the hands-on for the mode shape part of it, but I seriously hope you should have done till the natural frequencies. The natural frequencies of the simply supported beam were demonstrated to you, and in the last 5-10 minutes it was a monologue where I showed to you how you can use these natural frequencies to go one step further and indeed find out the mode shapes also as a simple extension of this calculation. So to conclude the story, what I have demonstrated is that symbolic computation can be very effectively employed to solve classical problems in vibration, and I think it is high time that in our respective colleges and in our respective curriculums we do this, not just as a part of teaching but even as a part of BTech project. If you can incorporate these sort of little things, it will help the students a lot in different ways. Firstly, it will help them to get rid of monotonous pen and paper calculation. They themselves will appreciate a new computational tool, and as I said in the opening, it will help them in getting good jobs also. And at the same time, the college will be able to highlight that they are using modern tools to teach a very old subject, which is vibration. It is not that an old subject should always remain old. We should sort of fashion it along with changing times. And as I said, most curriculum should adopt a CS plus X type of approach, where you try to implement all the good practices of computational associated with the exact the calculations applicable to your field. And this is one such calculation which is applicable to the vibration field. There are many more things you could do. For example, right in this thing, you should see that I have done another example which I could not show it to you for want of time, which is the forced vibration example. So in this example, we talked about a 4x4 system, homogeneous system. In the forced vibration example, we would have talked about an 8x8 system. So the matrix would be an 8x8 matrix, and it would be horrendous to try to solve that matrix by pen and paper approach. But in this computational framework, you would have seen that it's very simple. So this is the matrix that I was talking about. So this matrix can get inverted very effectively using this computational platform. But maybe you can do that as an exercise if you wish. But the objective of the talk, this 1.5 hour talk, is you should carry home this message that Python is not just meant for artificial intelligence and machine learning. It is also meant to do any computation. It is meant to do any numerical computation and also symbolic computation. And you can jolly well use this very advanced tool in your regular mechanical engineering teaching courses. And I hope you take this message home. You not only inspire yourself, but you take this message to your colleagues so that they can incorporate this. And it's not a big deal to learn. It is as simple as Android learning has been. Just play with it for a few days. You will learn it yourself. To be very honest with you, I have learned this over just one semester. Perhaps over the last one semester, I have been fiddling with these Python-based tools, and it has not been very difficult for me. And the best teacher anyway is Google. So whenever you land up into trouble, just Google your way out. You'll be able to find out a lot of help on Python because it's a freeware and it's a very well-maintained community. You should be able to walk your way through, and you should be able to incorporate all this in your curriculum. So that's it from me. But if you have any questions, I would be happy to address them in the remaining time.
Yeah, any questions? Yes. Sir, out of curiosity, I'm asking, sir, is there any specific reference you would like to suggest to our participants relating to this Python with specific mechanical engineering applications?
See, I don't think there is any book written for vibration with Python. Most books are written as data science with Python and AI with Python and ML with Python. But to be very honest with you, I think the best way to learn it is to do it. So just do it, and as you do it, that's why I wanted this hands-on session. And yes. I really hope that the participants also did it hands-on. Yeah. And I paused in so many times so as to enable the participants to be in sync with me. So I can tell you the only way to learn computation is to do it. No matter how many books you read, it doesn't really help. It's
Yes.
a good idea to have books by the side of your table, but you can never expect that you will read a book and only then you will do the programming. It's like,
Yes.
riding a bicycle.
Yes,
No
sir.
matter how much equations of motion you write, you have to ride your bicycle by yourself.
Yes, sir.
So the theory does help, but at the same time, you'll have to get your fingers dirty. There's no other shortcut to it. And I completely accept that you will be in trouble. See, the only reason that I suspect most participants didn't do anything at all, and I know I am on record, is because none of the participants had any doubt, which is very strange.
Yes.
So I don't expect that, 15 people have just learned Python in a jiffy, because it's very improbable that it has happened. So I know that since it is online and our cameras are switched off, most people have been doing something else. So that's fine. But whoever had this opportunity and hopefully benefited from it, maybe he or she will take this message on. Yeah. Anything else?
Yes. Any doubts from the participants, please.
Yeah, so as I said, questions arise when understanding is partial.
Yes, sir.
Questions don't arise when the understanding is zero.
Yeah.
Okay.
Yes.
So,
Excuse me,
I
sir.
mean, I don't, yeah.
Sir.
Okay. Yes, tell me.
Yes,
This is
please.
Tara Krishna, sir. Tara Krishna Manohar, sir.
Yes, tell me, Tara.
Sir, these things we can do in Maple also, no? So,
Yes.
is there
When
any
you were
necessity?
when you were with me in IIT Madras, you were doing it in Maple, but Maple is
2010 and 11 around
correct.
at that.
Correct. But the reason why I don't want to, I mean, the reason why I chose Python was that it is freeware. It is available
Okay.
for free, and you don't need to spend a penny to buy it. So all that you need is a browser, and that's it. You don't need to install anything in your computer. So that's why it has caught the attraction of a lot of people, that it is free and you don't need anything to install it. You can just use the online compiler, and once you are comfortable with it, you can install it. Installing it in your computer will make things faster. Computation will be faster. But there are certain subtleties associated with the installation, because there are lots of packages and you need to understand how to manage your packages. So it's best to use the online compiler when you are starting off. Once you get used to it, you can move on to your own system. Yeah.
Yes.
Sir, hello, sir. Good afternoon.
Yes,
sir.
hello. Yes, good
Sir,
afternoon.
myself, Praveen, sir.
Yes.
Sir, regarding AI and ML, sir, which is more relevant to the mechanical, sir? I mean, for data analysis.
Okay, I will say AI is as good as natural stupidity. I will prefer natural stupidity to artificial intelligence. Okay.
Okay.
So that's my answer. Be naturally stupid, don't be artificially intelligent.
Okay.
Yeah.
Okay, sir.
Yeah.
Thank you, sir.
Anything else?
Yes.
Sir, yeah. Thanks for the nice illustration, sir. Other open source tool that you mentioned, is it in terms of complexity almost similar in terms of coding?
What is your take as to Android learning? You must be having a smartphone, right, Mr. Chandra Kumar?
Sir, yes.
What is the complexity of it?
Initially, we thought it is strange when we first
No.
bought it.
Did it take? How long did it take you to
A
learn
few minutes.
Android?
Only maybe a few minutes or maybe.
And did you see that your kid learned it faster than you?
Yes, sir.
Do you know why your kid learned it faster than you? Why do you think kids learn Android or iOS faster than adults?
Yeah, basically, yeah, they're probably their creativity and ability is here in terms of digital.
No, but if you ask them to solve a vibration problem, they will fail miserably, no? But when it comes to, learning how Android is used and how smart TV has to be operated, they are very fast. Why do you think that happens?
Maybe the fresh mind.
Yes.
Whereas
Okay.
we adults, we think that, "Are Bapre, Python will come and bite me, MATLAB will sit on my head." These are all, whereas a kid is very innocent. He doesn't have any fear. Okay, so he explores and he or she gets it very quickly. Whereas for us in adults, we have many preconceived notion that AI is good and ML is bad and natural stupidity is bad and this is good. So we should not have any preconceived notion. If you wish to learn, just go head on and learn it. And see, the other question that you asked me is that which tool is better and which tool is worse. So let's say you have to go to the forging shop and you need to hammer out something. Do you really ask for which brand of hammer should you buy?
The requirement becomes
It's as good as buying a hammer. Okay, the hammer must have a minimum requirements in the sense that it should not fall out from its handle and things like that. But once you are reasonably sure that the handle is fitting tightly with the hammer, and the hammer has its weight correctly done, and it is well polished and it will not rust, I don't think we care about which brand of hammer we are buying, right? It is something similar in all these computational programming tool selections. I think it's more about marketing than anything else. That people say that use this tool or use that tool. And I am a big supporter of freeware. So freewares are very good in the sense that for those of you who don't want to spend or who don't have those infrastructure present in your respective organization, just use a freeware and get going. It really, I don't think there is any place where you will say that I could not do this because my computational programming platform did not allow me to do. It is not true that even if you take old languages like Fortran and C, you could do so many things with Fortran and C, and in fact Python itself was written in C. Okay, so everything is possible. If you learn C well, you should be able to do anything in C. But yes, higher level languages like Python and MATLAB are more user friendly than lower level languages such as C and Fortran. But in terms of ability, if you learn any one language through and through, you are all set actually. I don't think you can ever say that I could not do this because my language did not enable me to do it or it disabled you to do it. It is just how far you can take your computational programming aptitude. If you can take it all the way, you will be able to solve any problems which comes along. So my answer to your question is that there is actually no comparison. The comparison is between a higher level programming language and a lower level programming language. Languages such as C and Fortran are what is called lower level programming language. They are having a steeper learning curve and they don't offer these, jing bang and aesthetic appeals. They are pretty sort of minimalist in their approach. But tell you what, they are still, when it comes to saving computational time, when you talk about codes running into long hours, there is nothing which beats compiler-driven languages. So if you are actually having compiler programs like C and Fortran, they run much faster than Python or MATLAB because they are higher level languages. Higher level languages are more user friendly. It's easy to learn, but usually they cannot compete with lower level languages when it comes to computational speed. So that is the trade-off that you have to keep in mind. Lower level languages will be faster in speed. Higher level languages will be slower in speed. But unless you are doing very deep computation where it's running into days and weeks, I think higher level languages are preferable in that sense because it gives you a quick entry point and you can quickly start doing something. But eventually you will realize if you are doing very big computation, then you will realize that nothing beats lower level languages, compiler based languages.
Good afternoon, sir.
Good afternoon.
Hello, sir. Hello,
Yes,
sir. This is Praveen.
Yes.
Sir, actually, in Python programming, we got the roots, sir.
Roots meaning?
Roots we got, no sir. First node and second node nodes, sir. Roots, sir.
Yes,
Roots,
mode,
and
mode,
that is
not,
used for natural vibrations, sir. Natural
that
frequencies.
is the natural frequency. Yes.
Yeah, sir. Sir, doubt is actually our students sometimes they ask what is the use of finding these natural frequencies in this
As
particular
Professor Balade
condition.
Venkatesham said, that first most important use is if you have an excitation and the excitation frequency matches with the natural frequency, then
Yes,
you will have large vibration which will lead to failure of
yes,
your
sir.
machine. So you have to have a design guideline. So let's say
Yes.
you have a shaft, you have a simple thing. Any, as Professor Venkatesham rightly said, any machine is just a lot of rotating shafts, and rotating shafts will always remain. I completely agree with him. So if you have a rotating shaft, and rotating shafts will always have unbalance, so therefore there will be an excitation associated with the speed of the rotation. And if
Yes,
the
sir.
natural frequency of the shaft happens to merge with this excitation frequency, then you will have large vibration of this shaft, which will eventually lead to the failure of the shaft. So if you are designing a shaft, especially if the shaft is rotating at high speed, you have to have one design guideline. Let's say you want to design a shaft which is supposed to work at 1000 rpm. You have to ensure that the natural frequency associated with that shaft does not match with the frequency associated with the 1000 rpm excitation speed. So if it does, then the point will then your shaft will fail. So that's the importance of, that's the first, or perhaps the most important use of determining natural frequency, whether it is for a rotating shaft in a shop floor machine, or whether it is aircraft engines. The first thing that we will do is always find out the natural frequencies of your system and ensure that none of the excitation frequencies during the operating condition matches with any of these natural frequencies. Because if it does, you are in serious trouble, the design will fail. So this is the most important design guideline that you can educate your students about, that don't keep natural frequency same as excitation frequency. Excitation frequency will be known to you from the product knowledge. Natural frequency is something that you have to calculate. Obviously, it's only for simple structures such as beam that you can calculate it analytically. For more complicated structures, you may have to employ a finite element method type computation, but none the same, natural frequencies need to be determined, and the design practice is determine the natural frequency and ensure that they don't appear close to your excitation frequencies, because if
Sir,
they do, this thing will
sir,
fail.
this is applied for that only vibrating, or to reduce vibrations we need some devices. No, for that also it is applicable, sir. Suspension systems and other things, sir, like base. If any machinery is
I mean, finally, the suspension system together with the entire mass constitutes your system. So if you choose your suspension system in a lousy fashion such that together with the mass, it is causing its own resonance, and that resonance is merging with the engine excitation, then that's a bad suspension design. So the suspension is not in isolation. The suspension is a part of a system. You may be designing the suspension, but the suspension goes into a car. And the car, if you take the car body as the mass, or let's say if you talk about the engine can be taken as a mass, and the mounts can be taken as a stiffnesses. So the way you have to design the stiffness is such that the stiffness together with the mass does not cause a natural frequency which is near about the excitation frequency for the operating RPMs of the engine. If it happens so, then the engine will have wild vibration.
right, sir. Got it, sir. Thank you, sir.
Yeah. Anything else?
Yes.
Yes.
Gentlemen. Hello.
Yes, hello. Someone is talking about campus placements. Yes, hello.
Yes, any doubts? Or any clarifications you want from Dr. Abhijit Sarkar? Okay.
Okay. Thank you.
Sir. Thank you, sir. Thank you very much for your very inspiring session. And we have been receiving messages that the session is very, very interesting. And people are asking about the code. Some people asked about the code, sir. So
you can give it.
Yeah. Okay, sir. Okay. So we will be glad if you can share it, sir. That will be
So
very much
do I
useful, sir.
email Mr. Bhanu Prasad?
Yes, sir. Myself.
Oh, you are Bhanu Prasad.
Yes, sir.
Okay,
Yes.
Fine. I'll share the code. No problem.
Yeah. Thank you, sir. I will share that same to the participants, sir.
Okay.
And thank you very much, sir. You the very wonderful session we had, sir. And the fear of Python is almost out of our minds for the participants over here. Most of them, personally, I feel it, and of course, I personally believe in that's the view of many of the participants through the messages that I am receiving, sir.
Okay, I am not receiving those messages. So.
No, I'm to the WhatsApp group. I'm receiving, sir.
Okay, fine.
Okay. So, and thank you very much, sir. We will
thank you.
We will get back to you, sir. We will get back to you, sir.
Okay.
Thank you,
fine.
sir.
Bye.
Thank
Bye.
you. Thank you.
Yeah.
So thank you all. That's all for the day. And tomorrow we will join at 11 o'clock with Dr. Anand Pare from IIT Indore, sharing the session. So thank you very much for your kind presence and your time. And we will be sharing the feedback form to you shortly. And please be available to fill that particular form. Thank you.